Hello everyone. In this video, I'm going to go over the bike problem. So in this problem, we have namely 8 variables. You can just really read the problem and check that. I'm going to summarize it for you. So there's like men's model and women's model produced in 2 months, month 1 and month 2. And then we have inventories for both types. So we total have like 8 variables, and we label them as listed here. So men's model in month 1 production is just shown by X11. So the first index shows if it's men's or women's bike, and second index shows the month, if it's first month on the second month, and then X represents the amount produced, and then S represents the inventory amount. So this is what we got from the problem. These are the demand numbers. This is the production costs, and here you can just see the labor hours for each type. And we have current inventory given in here. So we have that list here. And to make it easy, I just write down the cost separately as a matrix. So for month 1 production and month 2 production, the cost is same, 120 and 90 per bike. And the inventory cost in the problem given to be 2% of the cost, production cost in here. So I just put 2.4, 2% of 120, and 1.8, 2% of 90. So for each month, that's the inventory cost. And you can also find these kind of like parameters here. And the company has some restrictions in here. We're going to go over that now in a minute. But first, I just created that cost matrix, and I put this amount here, the production and the inventory amount here. So if you want to find the total cost for this process, you see it's going to be some product of these 8 values here with the 8 values in here. So for example, you just put the production numbers for men, women, and we try to minimize the cost. So I'm going to use Solver to solve this optimization problem. So what type of constraint? So I hope this is clear so far. We just put the cost numbers, and we put the amount produced and the amount we have in the inventory, and that some product will give us the actual total cost. And we want to minimize it. We're going to work on that in a minute. So let's go over the constraints. Number 1, it says, first of all, you can just see that the demand, we have a demand constraint. So the constraints are written in here. This is the model that we have at the right side. I'm going to simply follow it. On the left column, I'm going to put those expressions, and I'm going to put whatever sign I have in between, and I'm going to put the expressions or numbers on the right side. Number 1, I'm trying to minimizing this function, which is the combination of this matrix and this one with the sum product. That's how I find it. Now, number 2, first constraint, the demand constraint. I need 150 at the end of first month. So how can I really determine that? It's kind of like 20 as the initial value, and then X11 is the production in the first month, and then S11 is the inventory that I have at the end of first month. So that gives me the demand. So this like S11 is kind of like leftover. So I have 20 plus production minus the inventory at the end of first month for the men's bike, and then if I subtract 20 from both sides, I get this. So production in the first month minus the inventory in the first month has to be 130 for men. And here we go. I just choose the first one. It's like production of the men's bike in the first month and the inventory of men's bike in the first month. I subtract them, and that should be equal to 130. Number 2, in a similar manner, it says the women's bike, we have a demand of 125. So here we go on the left side, and I subtract 30 from both sides. So I got the production in the first month for women's bike minus the inventory at the end of first month for the women's bike. That difference should be 95. So on the left side, I have B22 minus D22, which is women's bike production the first month minus women's bike inventory at the end of first month. So I subtract them, that should be 95. And then the equation 3, the demand now I need to go to second month. It's just first month inventory plus second month production minus the second month's inventory should give me 200 because that's the demand for month 2. So what does that mean? On the left side, I have first month's inventory plus second month's production minus second month's inventory. So that's going to give me the demand for the second month. And in a similar way, if you go to equation 4 for the women's bike, which is 150, demand is 150 for it in month 2, you have something similar. So that's like first month's inventory, whatever we left over from first month plus the production minus the inventory should give me 150. So it's kind of like month 2 inventory, here's the leftovers from month 2. So that means that's subtracted. So that should give me 150, right? And now also in the problem, it says at the end of 2 months, the company would like to have at least 25 units of each model in the inventory at the end of 2 months. So I need to have E21, which is the inventory at the end of month 2, to be greater than or equal 25, and similarly, E22, which is the inventory at the end of month 2 for women's bike, that should be also greater than or equal 25. So now we come to the last constraint parts for the 4. It says the total labor hours of labor for this for each month should not change by 100 hours. So in the last month, they used total of 1,000 hours. So that means in month 1, it should be larger than 11. It can be larger than 900. It should be larger than 900, and it should be less than or equal 1,100. So it should be, so the difference should be less than 100. That means you can go up to 1,100 as the largest value. For the smallest value, you cannot go below than 900. So what does that mean? That means 3.5 hours is just per bike, and X11 is the production in the first month, and X21 is the production in the first month for women's bike. I should have this one is, as you see, like 3.5 times X11 is the number of hours spent on production for a men's bike in the first month, and 2.6 times X21 is the number of hours spent for production of women's bike in the first month. So I combine them, I should be getting greater than or equal 900 or less than or equal 1,100. So it's right here. This is sum product. I need to multiply the productions by the labor hours, and that should be greater than or equal 900. And also the same expression should be less than or equal 1,100. So I choose these two, and I use sum product. So now the following month, we just said the difference of labor hours can't be greater than 100. So that means the difference should be either 100 or negative 100, but it's just written in this way. It's just the same thing between negative 100, 100 means you subtract the production, the number of hours spent in the first month from number of hours spent in the second month. That should be less than or equal 0. And if you negate it, then it should be again less than or equal to 0, because like we want this difference to be less than 100 on both ends. What does that mean? The hours I spend in the first month minus the hours I spend in the second month for the second month, the difference can't be greater than 100, because that's what it says. It's a low difference should be 100. And if you flip it, if you subtract the first month's production from second month's production, that should be again less than or equal 100. So you're kind of like on both ends, you're making sure that the difference is not larger than 100. So it's kind of like taking the absolute value and making it less than 100, because if you negate this, you get that the difference is greater than or equal to negative 100. So let's just put that in there. So that means I have sum product of the first month production with the labor hours minus the sum product of the second month production with the labor total. That should be less than or equal 100. And in the second part, I just use the same thing, but this time I change the sign. Can you see it? Like here, it is plus minus, but in here, it's minus plus. So I simply just negate it, and that's also less than or equal 100. So I'm simply following my model. So I hope it's clear so far, because we're done with this. So as you see, I implemented all these 10 kind of equations or inequalities here. On the left column, I put my left side expressions, and I put in the middle my signs, and on the right side, I put my right side expressions. This is really easy way this way is really simple, because you're going to put the same thing on Excel solver. So and I know my function. So let's go into here, data, and then I go to solver. On the solver now, I'm gonna go over this. So this is my total cost function. That's my objective function. And just make sure you choose this correct one. And the second part, please make sure you choose the correct type. We are trying to minimize the cost. So that's why you have to choose minimum. And then which cells am I changing? I'm changing these 8 cells. Those are changing, like monthly productions and inventory numbers. These are changing. And then what kind of constraints do I have? So if you look at this one, in the first one, they're all equal. So I choose the first 4, and then I set them equal to each other. Now on the right side, I put the right 4 numbers. So it's really that simple. You're simply comparing those expressions with those values or whatever you have in there with the left side expression and the right side expression. So this is what we have from the first one. From the second one, what I have is on the left side, I have this time the let me just check that again, but I have the left 3 because they're all greater than or equal, and on it's greater than or equal, and on the right side I have the right 3. So that's what I have. And the third one is I have those 3 now on the left side because all 3 are less than or equal to, and on the right side I have the right 3. So I'm ready to run my solver. But one more thing, this is usually in the nonlinear model case, you need to use simplex model, and then you'll click on solve. Once you click on solve, it's going to give you all those numbers for here. And then after you solve, please make sure you include the sensitivity analysis and answers, sensitivity analysis report and answers report to simply get the details about this problem, answer like more questions, what type of like kind of flexibilities you have on the problem. But yeah, as this is like a homework problem, I'm not just running it, but you just really, once you click on solve, it's going to give you all those answers in there. I hope this video helps. Thanks for watching. Bye.